In this video, we're going to talk about the different types of hypotheses that we can see in a hypothesis test when we're working with one population proportion. So for example, I got my inspiration for this problem from 538.com, where it talked about the graduation rates of students who started their education in fall 2009, because that's when technically the recession was ending, but even though its effects had lasted for years beyond that. So according to this report, 52.9% of those surveyed have completed their college schooling in a 2 or 4 year college within 6 years of starting college. So graduating within 6 years at some sort of institution. That rate is 52.9%. So the question is it possible to conclude that at least half of these students have completed college within 6 years of starting? Now, this question is posed because if we're just taking a sample, our sample could be off for all sorts of reasons. Maybe our sample wasn't good enough, or maybe we happened to just catch some weird students who took a really long time in our sample. So this is just 1,000 students out of the millions of students who go to college. So while we can maybe trust our results, we need to do a hypothesis test to see if our rate is really significantly above this number that I'm talking about. And this number that I'm talking about is at least half. And actually, I'm going to adjust it right now. Instead of saying at least half, I'm going to say more than half. Makes the problem a little bit easier by having that strict greater than, actually. So we're going to do a test to see if our 52.9% is significantly above half. So not just a little bit above, but really greater than. And it's all based on the width of that sampling distribution. So I'm going to set up some hypotheses. That's all I'm going to focus on in this video. Now, more than half, that's my key word there. Half, when we're talking about proportions, is 50%. And we would also write that as 0.50. So for our hypotheses, there's two different types. There's the null hypothesis, which is denoted with H0, and then there's the alternative hypothesis. Sometimes it's written as HA. Some textbooks use H1. It doesn't actually matter. A for alternative, it's easy to remember. 1 is different than 0. If you think of 0 as like your starting point, your baseline, it's what you're starting your comparison against. Then 1 is, kind of binary. It's the other stuff. So with our proportions, the 50%, we need to use the proper parameter in our hypothesis test. You always start off your hypothesis test with hypotheses because that is your number. Like, what do you have to compare your 52.9% against? You have to tell us. We're starting with 50%. The null hypothesis will always have the equal sign. I'm going to highlight that there. The equal sign always belongs in the null hypothesis. The reasoning is when we end up computing some numbers later on, we have to have a starting point. We have to have a fixed number to start with, and you have to fix a number by making it equals. So you have to have equals in your null hypothesis. For the alternative hypothesis, P, what's the alternate of P equal to 0.5? Well, we read the problem. This says more than half, so we want more than 50%. If I'm looking at a number line and I put 0.5 right there, 0.5, and I'm looking at more than 5, I'm going to highlight above there. We're looking at the right side, so more than, we're going to have a greater than sign. P is greater than 0.50. At this point, you might realize why I changed that wording up here from at least half. That word at least means greater than or equal to, and I can't have an equal sign in the alternative. The equal sign has to go in the null hypothesis. And to make this make a lot more sense than using at least, I went with more than, so you could say the word more or the word greater. If you'd see the word increased, and so on. These are just some synonyms to say greater than. you would use this greater than sign. Remember, alligator eats the bigger number. We're trying to say that the proportion is greater than 0.50. So that's all I'm going to do for this part, as I've just set up the hypotheses. H naught, HA, I have my parameter. Proportions, you just kind of use the regular letter P. There's no fancy Greek letter. You always put the equals in the null hypothesis, and then your alternative is some sort of greater than or a less than or maybe a not equals. And then finally put your number, which you have read from the problem. Sometimes when we're working with proportions, you use the word half and then it's implying 50%. Sometimes the problems will actually tell you more than 49.7%, and then you'd put that 49.7 over here. So I changed up the wording a little bit for the second example, and I want to say, is this 52.9% a change from the 56.1% of students who started college in fall of 2007 and then completed within 6 years? So we looked back a couple years and said, oh, hey, the graduation rate, the people who are completing college, was 56%. Is this a change from what the data we just collected? So I'd start off with my hypotheses, H naught, HA. Then you put a colon. Then we put our proportions. The null hypothesis is always equals. And this new percentage is, we're trying to see if 52.9%, that was our sample. I'm going to highlight that and say sample. Was our sample different than what we previously thought? 56.1.561. Sometimes your null hypothesis is a number that someone has gathered years ago, and we're trying to compare our new data against the old data. So my proportion here is the old data. You notice that there's not a sample size given. That's kind of a clue that that's going to be your old proportion. So some other words that we had, a change. If you see the word change, that is a clue that you're going to have a not equals in your alternative hypothesis, and then you put the same 0.561. If you see the word change, you want to use not equal to, because we just care if the proportion went up or down. It doesn't matter which direction. If you see the word is different, that's another way to say, hey, use the not equal sign. All right, and here we go. So our null hypothesis, P equals 0.561, and we're looking for a change. We want to see if our sample data has a proportion that's different than 0.561. Clearly, 529 is less than the 56, but you know, they just said the word change. So clearly we'll be on one side, but maybe it doesn't make a difference. We just want to see if there's something different. All right, last type of hypotheses here is 52.9% less than the 56.1% of students who started college in fall 2009 and completed college within 6 years. So now I took the previous problem and I just put into different words so we can see the last type of hypothesis test, and that is less than. So if you see the word less than or decreased, below, those are some synonyms for this other type of test. So put in our hypotheses, H naught, HA, P equals 0.561, and that keyword there, less than, we're going to say P less than 0.561. So in this type of hypothesis test, we want to see if 52.9% is significantly less than 56.1%. Yes, it is a little bit less, but is it really less to say, whoa, 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 something is going on here with these students who started college at the end of the Great Recession? It might imply something about those students or the effect of the Great Recession on those students. These three tests, I'm going to highlight them in a different way. They often have names. That word more than, and I was using greater and increased, this is called a right-tailed test. Right-tailed. And you can see that I shaded the right side of this number line, so that's emphasizing right-tailed. And also, the point of our little inequality there is on the right side if you need some help that way. The second type of test is called two-tailed, because we don't care which direction of change there was. Was it less than? Was it greater than? There's two different sides. This is called the two-tailed test. And then lastly, this is called a left-tailed test, because we're trying to see if our proportion is below some sort of fixed number. So that inequality sign, the little point is there on the left side. That's how you can remember that we have a left-tailed test. So there you go. Those are the three different hypotheses that you can run across with proportions. For averages, this is actually very similar. You just have a different symbol and some different numbers. But in general, a lot of your hypothesis tests boil down to three different types: right, left, and two-tailed in many instances.